Welcome everyone to another episode of Around the Block Talk. Today we have with us Mr. Zaryab Afser. He is the lead smart contract engineer and a blockchain security consultant and has spent multiple years in this industry. Today our topic for discussion would be demystifying Web3 and smart contracts and the security. So this is a very important topic in today's context. It's very important to get your smart contracts right, and we are very excited to hear what you have for us. I'll hand it over to you. Thank you, Zaryab.
Cool. Sure. Thanks, Prateek. Thanks for inviting me here, and all the best for all the things that you're doing. I mean, it's really interesting how you guys are expanding the boundaries of Web3 education. We need more people like you in the industry so that people are aware of what Web3 is. So yeah, that's lovely. A lovely introduction. I can introduce myself once again if needed. So I'm Zaryab. I basically, in very simple terms, I smart contracts and I create technical content on smart contracts. Now I work with EPNS, which is a world's first decentralized system that we're trying to build in the Web3 space, where we basically solve the problem of communication in Web3. I also work as a smart contract auditor with a few firms, which technically means I review code, try to find bugs, and report them so that we can protect people's money in DeFi. And whenever I get time, I try to create content. These days, it has been a bit less because I don't get much time. But yeah, I'm getting back to it. So yeah, that's pretty much my introduction. Maybe before I start sharing my screen, maybe it's good to discuss phases. I begin with the introduction of Web3, what Web3 is. Then I move towards understanding what smart contracts are, and most importantly, I mean, most of you know smart contracts. I want to focus on how do we approach smart contracts. What are people who want to enter the Web3 world and they're not sure. So the end part is for those people. There is actually a very interesting story as to why I start with Web3 and its origin. The reason being, I mean, all the previous shows that and the talk shows that I did in the previous year, I used to directly start with smart contracts. But very recently, I did a couple of IIL meets. I actually went to IIT as well, and there, before starting the presentation, I actually asked a very small question to the audience, and it was basically like, what exactly is the first few things that comes to your mind when you hear the term Web3? And I wanted them to be very honest with me, and they were honest with me, and it was really surprising when I heard the answers. And so, I mean, when I ask this question to people, I get to hear answers like, some of them, the very first thing that pops in their mind, some of the answers are like, crypto portfolios. Some of them talk about NFTs and their prices. Some of them go as far as talking about airdrops or lucrative APIs of DeFi protocol. Now, if these things are the first thing that comes to your mind when you talk about or when you hear about Web3, chances are you might have misunderstood or even worse, forgot what Web3 truly is. And that is really concerning for me because we cannot really build a better Web3 world unless we understand what Web3 truly is, right? So today's presentation is going to be about that to begin with, the origin of Web3, where is it coming from? And yeah, now I guess let me share my screen now that we have a brief idea of what the show is going to be about. So perfect. So, I mean, I already told who I am. We planned the journey. And now let's begin to understand what Web3 truly is, right? So if you have been in or around the Web3 space anytime soon, you might have heard this comparison of, Web1, Web2, and Web3, and why Web3 is better than them all. Now, truth be told, with all the important things that Web3 brings on the table, it has always been sort of a concern for, big players, the government, the banks, and central authorities. Which is why, since its inception, Web3 has faced a lot of issues, a lot of hurdles in its path. And we, as a Web3 community, in order to protect the grand vision of Web3, what we did was we started, simplifying and creating defensive statements of why Web3 is better, often comparing it with, Web2 giants, Google and Facebook, and so on. We created memes, obviously. We created tweet threads, bite-sized information of what Web3 is. Multiple people multiple narratives about what Web3 is. Uh, and we became so busy in glorifying Web3 or comparing it with Web1 and Web2 that somehow we forgot what it truly is, right? And so much so that if you go on Wikipedia right now and you try to look for what Web3 is, chances are you'll find a line that says, the specific term of Web3 is still very hazy. The vision of Web3 is not very clear to the world, which is a bad thing, and which technically means that apart from a very small proportion of Web3 thinkers and developers, majority of us don't understand what Web3 is. Uh, Actually, when I was starting the journey 3 years ago, I actually was in a similar situation. I was really confused with all the different narratives of Web3 and what it is. And then luckily, I stumbled upon this blog by Gavin Wood, who happens to be the person who actually coined the term Web3. In that blog, I mean, most of my knowledge about Web3 comes from Gavin Wood because he's the one who actually coined it. And in that blog, there is this beautiful comparison of Web3 with something called Magna Carta. Now, I mean, I might understand that this is a very alien term to most of you. So let me explain what Magna Carta is. So Magna Carta is basically a Latin word. In English, it means the great document. In very simpler terms, Magna Carta is actually one of the most imperative documents the history of humankind has ever seen. This is one of the documents that states that no king, government, or authority is greater than law, and it actually stops and prevents central authorities to exploit their power because it establishes law as the most powerful tool. Uh, and in order to understand the Magna Carta and the history of it, I'll have to take you all back to the history, uh, which is basically, let's forget about Web3 and technical side of things for a second. And let's dive into the year 1215 in the month of June. And in medieval England, there was this king called King John. As the world might know today, King John was perhaps the worst king ever because of the way he ruled his kingdom. He was one of the worst kings. He exploited all the powers that he had. He imposed heavy taxes on the citizens. He uh, punishes those who could not pay taxes. When all of these went beyond the limitation, the barons of England decided to finally, forcefully make the king sit down and talk to the king that this is not how you can rule it, and there has to be a law. Very luckily, it happened, and the king sat down, and there was this long discussion, and the entire summary of the discussion was documented down in this document called Magna Carta, which in essence became the foundation of freedom for any individual in this world against central authority control or government or those in power. So what Magna Carta says is basically no one should be above the law, right? And now it's interesting to understand why this was in a blog by Gavin Wood, is because Gavin Wood says that Web3 is nothing but an executable Magna Carta, which means that exactly similar visions, exactly similar fundamentals that power should not be in the hands of a few. Uh, those in power should not exploit it. Very similar views, but now Web3 enables to have an executable Magna Carta, which means we can impose these laws and without the need, most importantly, without the need of any central authority or any authority in control. This can be executed by a computer, right? Now, another way to look at the history of Web3 is the fact that technology often mirrors its past, which basically means that if you look at the past and the social structure that we had in the past, uh, it was mainly like power was accumulated in the hands of a few, maybe a king, maybe a government, and we all the other people had to blindly trust them that they will not betray us and they will protect us, right? And if you look at the web today, the web 2 part specifically, uh, you are free to do almost anything, but there is a governing authority. The entire power is in the hand of very few, right? So you want to send money to your family, well, you can, but then you have to trust the bank to validate your transaction, right? And you have to blindly trust them. It's a central authority. You want to send message to your friend, well, you can, but then you have to trust a Web2 firm like Facebook to relay your messages effectively. So enormous powers in the hands of very few, and the rest of us just blindly trust them, right? And this is exactly what's happening in the Web3 space today, which is why Gavin Wood also says that the internet today is broken by design. Now that we understand what Web3 is and where it's coming from, let's understand the three most important things that should pop up in your mind when you hear the term Web3 for the first time. So the first one is obviously decentralization, right? This beautiful term, which means that you know, eradicate any central authority control, and instead of relying on one single authority organization, we rely on a decentralized network, which is basically not a single authority or a government. It's basically a peer-to-peer network built on the community of users, right? And very popular examples of it is obviously Bitcoin and Ethereum that we can see. The second part, and decentralization is obviously something that we all are familiar of, but trustless is the most important thing, I guess, the second part of it. So what Web3 enables us to do is build trustless systems, right? So how do we do that? The first part that we understood, decentralization, that is there. Decentralization, along with its core, along with the blockchain's core components like immutability or transparency. So immutability, you know that once a data goes into blockchain, it's immutable, it can't be changed. So there is a definitive there is a security that we understand, it cannot be changed by anyone. Transparency, which basically means that every transaction on the blockchain can be verified by us, right? So decentralization, along with immutability, along with transparency, is what all of this combined is what allows us to build a trustless system. Which is why we say in Web3 that do not trust, simply verify. We in this era, we need not place our trust into any authority. We can simply verify things, and we can verify things when we have a trustless system built. And the third part, which is obviously the most interesting to me, is ownership. So if you look at the history of web and in general, users have always been users. I mean, all the people have always been users of the internet, but Web3 for the first time enables them to own pieces of internet, right? They can be the owner of the internet. So before this, you might have been using a product, but now you don't just use a product, but you can actually own the protocol by having voting rights to it. So there is something called tokens that we have, governance tokens, and some of the protocols have very successfully implemented on-chain governance, like Compound or Uniswap, or even we do at EPNS, which is the community has the right to decide what happens with the protocol next. Something as small as which audit company should we choose to audit our smart contracts, or something as big as what should be the new protocol function that we should have in our smart contract. Everything can now be decided by the community itself. The community have a say in the future of the protocol that we have now, right? So decentralization, trustless, and ownership together form the very core of Web3. And technically, these should be the few things that should pop up in your mind when you hear about Web3, instead of your lucrative APIs or airdrops. Now that we understand what Web3 truly is, it's time to understand what smart contracts are, or maybe now we're in a better place to understand what smart contracts really are. So can I have a temperature check? I mean, is everything fine? The audio and visuals are fine?
Yes, everything is working well.
Great, thank you. So, all right, so now we understand in a very simpler term. I won't really dive into a bit deep into this, but blockchain in its essence is basically an open distributed ledger that can record transaction, not just in an efficient manner, but also in a verifiable and permanent fashion, which means immutability, transparency, and decentralization that we discussed about Web3 together. It's all combined in what blockchain does. Now, with the 9-page long white paper, like Satoshi Nakamoto for the first time showed the world how significant imperative it is to transact without the need of any central authority. And since then, now Web3 has come a long way. We have enormous cases of blockchain and smart contracts in different domains, mainly in finance. And the TVL, the total value logged in DeFi, has grown exponentially, right? Now, despite that, one of the questions that might pop up in your brain is blockchain technology alone capable of this wide range of use cases? I mean, think about blockchain for a second. It's static in nature. Like it has really cool features like security, immutability, and transparency. But then you can either store data to blockchain or retrieve from it, right? But when you think about complex transactions or complex smart contract functions like flash loans, or maybe algorithmically controlled stable coins, blockchain alone is not capable of doing it. So the question arises, what exactly allows us to do that magic? And that's where smart contracts come to the picture. So which is why I say at the heart of blockchain lies smart contracts, right? And now let's understand what smart contracts basically are. So we cannot really begin talking about smart contracts unless we discuss about the person himself, Nick Szabo, who was actually the inventor of smart contracts. And unlike how most of us might know, smart contracts are not did not come after Ethereum, but it were there before Ethereum was came into existence. Ethereum just found a very effective way of implementing smart contracts. So, in very simpler terms, what exactly are these smart contracts that we know of? So, smart contracts basically are self-executing digital contracts, right? Uh, it does not need any third party to execute it. So smart contracts execute whenever a particular condition is met, right? And the reason smart contracts are called law is because no one can change it. It's immutable in nature. So once you have coded a smart contract, you cannot change it. I mean, there are ways of upgrading a smart contract, but that also happens with a specific discipline. Uh, Smart contracts, in essence, they wipe out the central authority control because now code is able to not just document the laws but also impose the laws on the users. And like I mentioned, like we know what smart contracts are. We all have a high level overview of it. But what's more interesting to understand is how exactly that do we build smart contracts, right? And when we build smart contracts, how exactly do we build out the architecture of it, and what should be the design process? So to explain that in a very entertaining way, I thought of an example, which is Alice, Bob, and the smart contract. So let's understand this example and what exactly is the objective here. So let's understand that there are two actors, Alice and Bob, from two different corners of the world. They both want to do a trustless transaction, which is basically they don't know each other. They don't want to know each other. They just want a transaction to happen. What exactly is the transaction? Let's say Alice is supposed to deliver a sort of product, or let's say a freelance service to Bob, and instead of it, in exchange of it, Bob will give some money to Alice, right? Uh, Now they both try to explore what are the best ways that they can do this, and they find there are two different ways. There is a traditional escrow contract that they can do, and second is they can use smart contracts. Now when they try exploring how better can this be done, they find out that there are certain cons when we do a traditional escrow contract. So the first part obviously is they want this transaction to be trustless, but when you use a traditional escrow company, you put excessive trust in third parties, and you trust that they will do justice to this entire transaction, right? Second part is it deterministic? Maybe not, because in any process when humans are involved, the chances of errors goes up, right? What about the speed? So they might want to do this transaction on a weekend, but chances are that the company might not provide services on weekend and holidays. Even if it does, the entire process might be too time taking. It's heavy on the wallet because whenever there is a particular process with a lot of middlemen involved, chances are the cost of it increases. Is it reusable? No, because if they Alice and Bob want to do this transaction over and again, they might have to create new contracts again and again with the company. So they decide that okay, there are lots of cons in the traditional escrow contract, so we should use a smart contract. Now, understand this scenario first. So there are two people who want to do a transaction. Alice wants to send a freelance service to Bob. Bob wants to send money to Alice, and all of these should happen without any central authority control, without any bank, or without anyone in charge of making this entire thing happen. No third parties at all, only the smart contract. Now, when you think about it this way, you feel that there is a lot of responsibility for the person who writes this smart contract, because technically the smart contract will be the law, and it should act very effectively, because if not, then they might end up losing their money. So, which is why I use this example, because it beautifully defines how we can develop good smart contracts. So, what exactly are the 2 points that you need to understand? The first is defining the checkpoints. So, maybe trying to understand what exactly are the tricky points in the smart contract development process that's going to be there. And the second part is designing the game theory, which basically means since smart contracts are going to be the law and there is no external authority that will govern it, we need to find a way uh, that the game theory is very effective. Which basically game theory basically means that algorithm which is win-win for everyone, and while it rewards the best actors, it also is capable of punishing the bad actors. That basically what game theory is. Okay, now let's think about the checkpoints that we have, or the blockers that we have while designing a contract for Alice and Bob. So I mean, there can be a lot more blockers, but just to make this very uh, simple and effective, I just took three examples. So what if Alice never initiates the transaction, right? So maybe Alice says that, okay, I want to do this service for you, but she never does it. What if Bob never confirms? So maybe Alice does the freelance service, she delivers it, but Bob refuses to pay. He says that, no, I won't pay. What happens then? And what if the transaction is never completed? Maybe both want to do it, but the transaction never is completed. So these are the few checkpoints that we might have to deal with while developing the contract. And this is even before we start designing the contract. We have not even started coding yet. This is just the thought process that goes into developing the smart contract. All right, now let's define the rules and the laws of the smart contract. And maybe after that, I can come back to all these checkpoints and see how we have eliminated them. So the first rule is Alice must lock X amount of tokens, which basically means if Alice is really serious about getting this transaction done and really serious about providing her freelance services, she will just lock X amount of tokens into the smart contract, which basically shows that, okay, she is serious about this entire thing. Bob must lock X plus Y amount of tokens in the smart contracts. Why X plus Y? Why more than Alice? Is because uh, think about it this way. Bob is a very interesting character here. Bob is the one who confirms the transaction that, okay, I received the delivery of the product and now I can initiate the payment, right? So because only after Bob confirms, this entire transaction will be completed and will be considered valid, which is why Bob has a lot more skin in the game and he is the sort of deciding factor. So if he stakes more than Alice, chances are he will never be a bad guy who will just take the product and run away. He will, because he has more token stake than Alice in the smart contract, which is why he is bound to complete the transaction. So then we have these two rules, and then Alice initiates the transaction. Both parties withdraw the locked funds only after Bob confirms, and we know Bob should confirm because, again, game theory, the contract will punish Bob if he doesn't confirm the transaction. And if no transaction happens within a predefined amount of time, the funds are unlocked for both parties, but after a deduction of penalty fees, which basically means you both showed up, you wanted to have a transaction, but you did not fulfill the criteria, and which is why we are deducting, the smart contract is deducting a particular fee, and only then they were getting the money back, which is a loss for both of the parties. Now that we have these rules, and by the way, there can be a lot more rules and a lot more checkpoints, but this is just to make you understand how to approach designing a contract. Uh, Now that we have these rules, let's look at our checkpoints that we were discussing initially, these three. So the first was, what if Alice never initiates the transaction? Well, Alice loses her log tokens in the smart contract. If she never initiates it, which means she was sure about it once, but now she doesn't initiate it. But the smart contract already has her tokens, right? So if she plays a bad actor, her funds are lost. What if Bob never confirms? Well, he has staked more token than Alice, so he should he would actually want to confirm the transaction and get his token out, which is why a perfect game theory for making Bob a good actor and behave like a good actor in the entire transaction. What if the transaction is never completed? Well, funds are locked, but with the penalty fees. Uh, this penalizes bad behavior. Now, if you really think about it, a smart contract, with the help of smart contracts, we did not just document the laws, that, okay, everyone should behave nicely and this transaction should happen very, very effectively. We are not just documenting the laws, but we are also able to impose the laws. Because if Alice or Bob, anyone plays as a bad actor, they are penalized. So smart contracts are not just there for imposing, for documenting the laws. It can impose the laws, and most interestingly, without any need of central authority, which is very interesting. Okay, now that we understand how to approach a problem while solving smart contracts, and these brainstorming sessions might be very longer, because you know that you are building a code that is going to be immutable. You won't be able to change it once it's on the blockchain, which is why discussion and having these thought processes and checkpoints and going through them again and again is very important. Now that we have a specific document created, that, okay, these are the terms we want in the smart contract, it's time for you to convert them into actual code, right? You can choose any smart contract language. If you're choosing an EVM machine, chances are you'll go with Solidity. But yeah, you can choose any code, and you can basically convert this entire document, entire terms that you decided previously, into code. right? Once they are decided and the code is developed, then comes testing and auditing. I will come to the auditing part later. But yeah, testing of the smart contracts is very important because, like I said, they are immutable, and which is why we need to understand that the way we want to behave the smart contracts, are they behaving in that way or not? If it is not, then we need to constantly change and modify the functions so that they behave exactly the way we want them to behave, and they cannot be attacked by a malicious actor, which is why testing is really important. And then once the testing is completed, we deploy it on the blockchain. The blockchain has a smart contract, and then we can basically interact with them, and we can rest be assured that the contract code will never be able to change. No one will be able to change it, not even the developer, because smart contracts are immutable in nature, right? So with this example, we understood, how exactly can we approach developing a contract, and what exactly should be the thought process. We should think about the checkpoints. We should think about the game theory before designing the contract. And yeah, once it's done, it's our responsibility to test the contract actually. So the significance of smart contract that Bob and Alice found was, it basically not just defines but enforces the rules, and they don't need to rely on any third party, which is elimination of third party interference. These are deterministic because these are code and there are no humans involved. They know that the code will act the way it should and the way it is defined, and it's very deterministic in nature. It's cost effective because now that we don't have middlemen, we don't have a lot of extra expenses that we had to that we might have if we have chose traditional contract. It's cost effective, it's reliable, and it's faster. Now that we understand the significance of the smart contracts and all about and all the sunshine and rainbows, is it really that, or are there any concerns with the smart contracts as well? Because I also come from a smart contract security background, I have been working in the audit space. I know that smart contract might be a very beautiful tool, a very interesting one, but it has its own limitations as of now, and which might need to be fixed. So to begin with, one of the major one is security. Obviously, you might have witnessed the year 2020, and still there are a lot of smart contract hacks. Some of them are because of logic errors, but most of them are also because of financial issues, like price or manipulation. Second limitation is the immutability of a smart contract, which basically means immutability is the feature that is glorified about smart contracts, that if smart contracts are immutable, you can have a lot of trust, that the code won't be changed. But think about it this way: every smart contract is basically a piece of code, and codes are supposed to have bugs. Now, bugs is not really a great deal when you are writing a code which can be fixed later. But with smart contracts, bugs are a really great deal because you cannot really change the bug if it's deployed once on the blockchain. And that is actually a limitation of the smart contracts. Upgradable contracts solve this issue to a lot extent. But again, even upgrading contracts has its own limitations as of now. Excessive dependency on the underlying blockchain. So this is where, this is a very interesting problem that at least the smart contracts that are on Ethereum blockchain, they rely a lot on Ethereum's underlying architecture. So tomorrow, if Ethereum undergoes a very significant change in the underlying architecture, chances are your smart contract might not execute the way it should, right? Fourth point is nascent stages. So smart contract as of now are at the very nascent stages. I mean, we are just at 0.8.12 as far as I know in the Solidity versions. And if you have looked at it, every Solidity version that comes up, it basically solves some sort of bug that was in the previous version, which technically means that every version you might have used in Solidity, it might have had some sort of bugs in it on the language level, which you might be unaware of. And basically these bugs are what leads to major hacks sometimes. And the last point is inability to interact with the real world data, which technically means all these interesting features that we have in smart contracts, security, immutability. It basically comes at a cost that smart contracts are a black box. It cannot interact with the real world. And that sort of is a blocker on a lot of different implementations of the smart contract. But then you have price or manipulation that solves this problem. So these are some of the limitations of the smart contract. And now let me talk about the very first one, which is security. So is the voice clear?
Zaryab, can you?
Yeah.
Yes. You're breaking a little bit. I think if you turn off your video, the quality of your audio will be better.
Sure. Perfect. Is the screen visible now?
Yes, screen is there.
Sure. Is the voice clear?
Yeah, better. You can go ahead.
Okay, perfect. So now let's talk about the security side of smart contract. Now, the reason I have the DAO hack mentioned here is because this was technically the mother of all smart contract hacks, which technically means uh, before that smart contract hacks were there maybe, but this was one of the biggest ones in 2016. And technically, it is believed that almost 15% of the total Ethereum circulation at that time was in this smart contract, and it was hacked because of a very very silly solidity like smart contract design error, which led to a reentrancy attack, which technically means an attacker was able to re-enter the contract again and again and wipe out all the Ethereum that was there in the contract, all the Ether. And since then, smart contract hacks have been taken seriously because the repercussions of a hack can be really disastrous. I mean, there was a hard fork, and Ethereum was divided into two different chains, Classic and Ethereum, uh, which is why we understand that if a hack occurs in any smart contract, the chances of the entire chain and the entire blockchain getting hampered is very high, because then people start losing trust, and which is why it's very important for us to take very good care of security when we develop a smart contract. And which is what makes smart contract development a bit tricky, because now you don't just code, but you also technically you're also coding something that will later on store money, and when it's money, it's a lot of responsibility, right? So the DAO hack happened, and then came the year 2020, which almost shook the Web3 world, because there were a lot of hacks, around 100 million of the total losses were there in 2020. And this was basically the year that caught my attention as well, and when I actually started into auditing field. So if you really look into 2020, the type of attacks that we were facing were completely new. Now we did not just have reentrancy attack, we had price oracle manipulation, we have flash loan attacks, we have new sort of solidity logic errors, and all of those combined, like BZX, Harvest Finance, and all these big names in the Web3 space, all of them were somehow attacked. Now, if we really think about it, are there any possible solutions to prevent smart contract hacks? I mean, it's understandable that Solidity as is at its very nascent stages. We are still learning and growing, but there is still a few proven methods that can actually help us develop secure smart contracts. Which is, the first one is, I mean, basically practicing the best security development practices. While developing smart contracts is very important for us, first of all, to be up to date of what exactly is the version we are using, and be up to date that what exactly are the checkpoints or the blockers in that version that we are using. Because Solidity is at its very early stages, there are new versions every now and then. There are new attack vectors every now and then, and we need to design the contract keeping in mind all those things. So it's slightly more important for smart contract developers to be active and really look out for any new changes that happen in Ethereum or the smart contract Solidity language. And the second part is performing extensive security audits. Now, this is a process that basically allows a smart contract developer to have a fresh set of eyes, the auditor's eyes on its code, and chances of getting errors, increase when you do an audit. Now that we're talking about audit, maybe I can give you a very brief glance at how the entire audit process looks like, and at least the process that I have seen and followed in multiple firms that I've worked with. So to begin with, it's really about understanding the code. And for that, you need to understand the audit scope and the documentation about the smart contract. So this is important, because even before you look at this code that you're about to audit, it's important for you to understand how exactly that code was supposed to behave, right? And that's where documentation is really helpful. So I mean, if you enter the audit world, try to take a documentation first from the client, or the smart contract developer, just to understand how exactly the contract is supposed to behave. Then the second stage is basically evaluation of test cases. uh, Test cases are really important, not just because they ensure that all the cases have been covered, but it also gives the auditor an idea that, okay, this is the way this contract was supposed to behave, and this is how the developer wants us to behave. And then it's also a very good point for us to try to break it. and see if it can be hacked, right? Once the documentation gathering and the test cases are done, and we know that they are pretty good, we begin with the automated testing. Automated testing, in very simpler terms, is running a few tools on the smart contract and basically asking the computer, hey, tell me what's wrong with the contract. We can use tools like Slither, Mithex. I personally use Slither, but yeah, we can use these tools to run automated testing. But there is one important point that I would like to mention here. Automated testing tools, right now at least, are not that effective. The reason being, in the Web3 world, we are facing new attack vectors every now and then. And the automated testing tools are not really capable of, at least at this point, not really capable of identifying all the issues that a smart contract might have. So what they basically do is they basically give you an automated result based on the previous hacks that have happened, like reentrancy or access control issues. But chances are those may be a false positive or a false alarm, because smart contracts, I mean, at least now, almost everyone knows that there is a reentrancy attack. And chances of you getting a reentrancy bug in a smart contract is very less now because people are aware about it. But the automated testing tools don't really catch the new attack vectors, and they are not developed enough to catch them, which is what brings me to the next step of the auditing, which is manual code review. For me, this is the most effective step in the entire audit process, because this is where I basically go through code line by line. If the code interacts with multiple protocols, I might have to look into those protocols as well. Manual code review allows you to read the code, understand it, and then try to break it, deploy it on the blockchain, and try to break it in different ways. And which is the reason it's very effective. It's because it's really important for you to look at the code from fresh perspective, and also consider the new attack vectors that are in the market right now, right? And which is why manual code review is so important. So once the automated testing and manual code review is done, the fifth most important step is adequate documentation of the reports. This is important because of two reasons. First, uh, as an auditor, it's your responsibility to not just report the findings, but also provide recommendations of how the issue can be fixed. And if you have done a very bad documentation, chances are the smart contract developer might not understand what exactly we're supposed to mean. The second reason for documenting reports very well is because when someone develops a smart contract, the community members will put in their money in that smart contract. And before they put in their money, it's their right to know if this contract is secure or not. But not everyone can read Solidity code. So it's very important for us to, as an auditor, to write effective documentation so the community member can also understand that, okay, this contract is pretty secure or it's not very secure, and the issues that it has is not really looking that good, and I should not put my money into it. So as an auditor, you have to write really good documentation, explain the issues, and then explain how those can be fixed. So it acts not essential tool for the smart contract developer, but also for the overall community who cannot really read code and basically relies on the auditor's report to understand if they can invest in the smart contract or not. So these are basically the five main steps in smart contract auditing. And yeah, that's pretty much the second phase, second stage of the presentation. Now let's move to the final stage, which is, if you are someone who wants to enter the Web3 world, how can you do it? Although I'm a developer, but it's not really important that you want to enter the market as a developer, right? So if you are a writer, basically, like I mentioned in the starting of my video, the Web3 world still needs better storytellers, someone who not just glorifies Web3 every now and then, but also focuses on why Web3 is important, and at its very core level, right? If you are a designer, I mean, you might have seen the UI UX experience of Web3 and the dApps right now is pretty pathetic. It's very hard for layman to understand how to use MetaMask or how to connect them with the dApp and all the Ethereum addresses. So if you're a designer, UI UX designer, you might work on beautifying the entire Web3 world and make simpler tools for the Web3 community, so that they can interact very well. If you are a Web3 enthusiast, maybe you can join a community and contribute there by being very active in the governance proposals, writing blogs, simplifying complicated topics for the Web3 world. And finally, if you are a developer, then yeah, welcome to the house. I mean, that's the most interesting, like exciting thing you can do in the Web3 world. So because I come from a development background, so I will guide you maybe in 4 different steps on how you can start your journey. So even before step one, I like to put step zero, is because it's really important for you to understand the history of web before you understand Web3. The reason is, the significance of anything can only be understood not by what it is, but what problem does it solve, right? And you cannot understand what problem Web3 solves unless you understand the history of web in general. So if you are a complete beginner in development, chances are you should understand what web is in the first place, how basic programming languages work, JavaScript maybe to be very specific, how APIs work, and all the basic stuff, and then move to Web3. However, if you are already a developer in the Web2 space, then it's good for you because you can begin with the step one, which is understanding the blockchain and Ethereum basics. So this is, I mean, I have started with Ethereum, but there are multiple blockchains right now, and you can start with any one of them. And before you start actually developing on them, it's basically important for you to understand the basics of it and the underlying architecture of it. So let's say you're starting with Ethereum, you need to understand the basics of Ethereum architecture. What exactly is EVM and why it's called Turing complete, right? What exactly are transactions, gas, and how to use MetaMask to begin with. And most importantly, you should also understand how to look into Etherscan Block Explorer, because not everyone can see into the technical side of the blockchain, but Etherscan allows us a very interactive UI that allows us to see all the different things: transaction fees, gas used in the transaction, the ether value passed in the transaction, which function was called, and everything. So this is the very stage one and the basic step. Then you move to the second step and you understand how a smart contract works. Most importantly, the thing that we just discussed previously, how to approach developing a smart contract, right? How to test them, and how to interact, how to make smart contract interact with the front end using Web3.js or Web3.py. Uh, just to drop some of the learning resources that you might find on the internet, Solidity documentation is one of them. But if you are beginning, it might be very hard for you to understand the documentation, official documentations, which is why Crypto Zombies is pretty popular, and you should start with that as well. Chances are you might not find a very structured course at this point, but it will basically be a mix of YouTube videos and Medium vlogs. And then coming back to Solidity documentation, just to get the concept right about different things. When you are trying to look into development, then you may use Remix to begin with. It's a very user-friendly online IDE. And then when you go into advanced smart contract development, you can end up using Truffle or Hardhat, Nash, and Brownie if you're a Python lover. But I won't stop there, because smart contract development, if you are learning the basics, you are not fit for the job, because smart contracts have seen a lot of use cases in the DeFi field. And because they have seen a lot of use cases in the DeFi field, chances are if you are hired as a smart contract developer, you will end up working on DeFi one way or another, right? And if you are working on DeFi, you need to understand a few terms in Web3 and smart contracts specifically. To begin with, there are ERC standards. So ERC20 token, what is fungibility, non-fungibility. You need to understand what is ERC 555. You need to understand how upgradable contracts work, because like I mentioned, smart contracts cannot be upgraded. I mean, cannot be changed. The code cannot be changed, but upgradable contracts actually provide us a way to change the function logic, in the implementation contract. And there is a proxy pattern that we follow. So you need to understand how those things work. And if you are into smart contract development, chances are you have to understand the DeFi terms that we have now, like lending and borrowing, or flash loans, or on-chain governance, or staking, or at the very basics, what exactly is tokenomics, right? You can learn all this by using the projects or reading about the projects like Uniswap, Aave, EPNS. But yeah, you need to do these things, and this might take a couple of months, because only after you understand how DeFi works in general, or how very basic things like token and non-fungible token works, is what makes you fit for the role in the Web3 space. Because learning just the basics of Ethereum and Solidity and making simple contracts is not really something that recruiters want to see. And I've been hiring a few people for Solidity roles, and I see that just because there's less content available on the internet right now, doesn't mean you should stop there. You should have the passion to learn more about DeFi, at least, so that you can understand how to get a job in the field. And finally, I mean, you can stop your journey here as a smart contract developer, but just in case security, catches your attention a lot, then you can take a step ahead and make your hands dirty with the all the security resources that we have available right now. So to begin, if you are looking for a security auditor role in the field, you should understand to begin with what exactly are the different attacks that have been there till date. All the attacks that have been there till date, like reentrancy or flash loan or access control checks, Open Zeppelin is, by the way, a very good tool, a very good resource that puts out, a lot of audit reports and also a very educative contents that you can learn security from. Uh, Most important, I have personally loved them. When you play and learn, that's the best experience. So there are certain CTFs available right now, which are basically games where you try to hack smart contracts. They are damn vulnerable DeFi, Ethernet, and capture the flag. I can maybe drop this links with Prateek as well so that he can share with the community. Other security tools that you might want to use when you are as an auditor is basically Slither, for the automated testing, Mithril for security analysis. Surya is a tool, very interesting one, which basically helps you visualize the entire contract architecture. So when you are dealing with contracts that are 200 or 500 or 1,000 lines, it's not a big deal. You understand that this is just one piece of contract. But when you're dealing with multiple contracts, like 1,000 or 5,000 lines codes, and they're interacting with different other contracts, then it's very important for you to have an eagle eye perspective of what exactly the whole architecture looks like. And for that, Surya helps you a lot. Tenderly is a new one, which helps you in the smart contract alerting and monitoring system. And yeah, you can basically get an alert for every time a transaction fails, or even better, you can also debug the failed transaction and understand how it failed. So these are some of the tools that you can use. And finally, I like to end this presentation with saying, like Spider-Man said, with great power comes great responsibility. And when you're writing Solidity code, you have to understand that these code will someday store a lot of money. And whenever there is money involved, there are going to be malicious actors who will try to break your code. So as Solidity developers, you are basically designing code that will store money, a lot of them. And because of that, there is a lot of responsibility on your shoulders to do it right, to test the contracts accordingly, and to make sure that they're audited well. And this is how you ensure that the contract is very safe and you don't lose the money. And basically, yeah, having the power to code such a thing that you can store money is a great power. And yeah, with great power comes great responsibility. So yeah, that's how I would like to end it. It's really been awesome being here. Thank you, guys.
Yeah, with that, thank you, Zaryab, for a very informative talk. And I think indeed you put a lot of passion into your presentation. You put a lot of relevant information. So that was very good to see. So probably we can have a little bit of a
Thanks, Pratik.
Q&A.
Sure.
Zaryab, as you mentioned, so we have to first get the game theory right in order to get the smart contract right. And you gave us some example of two people transacting and how that might work. So I believe that's a basic example. So on a larger
Right.
scale, when there are multiple interactions and probably there are simultaneous transactions, one person is simultaneously possibly transacting with multiple people. So how does these systems shape up, and how do we actually get the game theory right in larger systems?
Got it. That's an interesting question. I mean, game theory is a very essential part of DeFi in general, and I can maybe give an example from what we develop at EPNS. So, for example, at EPNS, what you can do is basically create your own channel. Once you create your channel, you have the power to send notifications, right? But then you are also not allowed to spam your subscribers, right? So if you spam your subscribers a lot, that's basically a bad activity on the protocol. And the game theory is designed in a way that when you create a channel, you basically have to deposit certain amount of push tokens into the contract. Once you have deposited it, you are making sure that you are really serious about this channel. You are really dedicated to it, and that's basically the token that you have deposited in the contract. But if you start behaving like a malicious actor or a bad actor, chances are the on-chain governance and the community will decide that this actor is a bad one. And through an on-chain voting, which is what we are developing right now, you will basically be able to block that channel forever, which technically means that once the channel is blocked, he loses his tokens. right? He loses the power to send notifications anymore, which is what we have. And for example, the channel is really good and the channel owner is good. We have a way of rewarding them. So with through the help of smart contracts, we are able to reward the channel owners if they are nice channel owners, and we are also able to punish them if they are bad ones. Yeah, this may be one of the examples that I can get from my experience. Yeah.
Sure. So I think in terms of the game theory, so one key factor that smart contracts are going to support is the token economy, how the
Right.
tokens are generated, distributed, how they are interacted. So that's, I believe that's another entire another
Yeah,
world on
definitely. That's another good point. Yeah.
how to get the token economy right, and how do you incentivize
Yes.
the different players
Exactly.
correctly. So, what kind of opportunities do you see, let's say, career opportunities for students or for even for all kinds of people? So, I think this is something on top of a developer. I mean, a little different
Right.
kind of a thing. So, that is not core development. You have to develop the game theory, you have to develop the economics side. So, so this
Hmm.
is, I think, a new job description that is going to come up. So, what kind
Definitely.
of people and what thing can be done here?
Got it. So that's a very interesting thing. So I see a lot of conjunction between finance and development when I talk about smart contracts. If you really look at it, some of the hacks that happen in smart contracts are not really even because of solidity bugs. They are because of the fact that the developer had very little understanding of finance, and they ended up making something that was ultimately hacked because of price correction manipulation or arbitrage trading. Because of the fact that developers, even me, I don't have a finance background. So the career opportunities that I see, I mean, people who are really good at finance, they can, I mean, there are some already. I don't remember the name right now, but yeah, if they're really good at finance, they can help a project design their tokenomics. Tokenomic design is it's such a complex thing that even I don't expertise in that right now. But it is something that, it could be really interesting if people from finance help us design the tokenomics, not just tokenomics, but if something is very financially inclined, a DeFi protocol, they can also help in designing the architecture of it at least. That's for the people in the finance sector. But people in general who are looking to break into the Ethereum or Web3 space, there are a lot of different opportunities right now. Even if I don't speak about development, there are, like I mentioned, right? If you're a writer, there are writers that are earning a lot more money than they would in Web2 because they're trying to break down complicated Web3 or DeFi topics that has not been defined yet. So if you're a designer, there is a lot more opportunity for you to beautify the whole UX. And then if you're a developer, I mean, for that, you should basically start with the basics first. But then if you have an understanding of the Web3 space, you can start with smart contract development first. And yeah, if security, if breaking things interests you more than building things, then auditing is your thing. You can definitely start with auditing as well. So these are some of the very cool options.
Sure. So I believe, as you mentioned, the first layer would be to get the game theory right, and the second layer
Right,
then would be to get your conditions right, as
right,
to
exactly.
what happens when. So after that, you move on to actually coding those conditions. Now, in order to
Actually
get
coding the
those
ones. Yes, yes.
right, in order to get those conditions right, so is that kind of a legal expertise that is required here, and what are the requirements to get those conditions right, to get those interactions right?
Not necessarily a legal expertise. A
Mhm.
financial one maybe. If you are trying to build a DeFi protocol that is very heavily inclined towards finance, maybe you need a financial expert. But it's usually the team sitting and deciding what exactly are the conditions that might occur in the smart contract and how exactly should we design them. So these are long brainstorming sessions that the team can have. I mean, even without the need of a legal team, we can actually do that. Maybe developers can do that very well, but I mean the problem with developers, I mean I myself am a developer, but the problem is sometimes we see very one dimensional and when we are talking about finance, we might not be able to see a lot of things that a financial expert can see. So having meeting with them and trying to understand through their lens how we should design something, it could be really effective. Yeah.
Right. And like while building those conditions, you really have to think it through because you're going to
Yes.
put it there forever,
Yeah.
right? So
It's
I
going to be
believe,
there forever almost. Yeah. Yeah.
yeah, that requires a very exhaustive exercise of considering all possibilities And
Oh yeah,
so,
yeah. I mean, we have a saying that development is just 20 to 30%, 70% is just brainstorming, and that's the hard part. So yeah, it's definitely very important.
right, indeed. So, I believe there's this concept of upgradable smart contracts
Yeah.
where eventually if the environment changes and you feel that conditions are not working, you can probably change your conditions.
Yes.
So how does that work?
Got it. Definitely. Good question. So, I mean, even the contracts that I build, and I recommend people to actually build smart contracts that are upgradable because, like I mentioned, code is after all a code and it's supposed to have bugs. So, the way upgradable contracts work is basically in general contracts, when you deploy a contract, you get a particular address, right? So, all the contract is state is stored in that address. And if you somehow decide to change the address or deploy a new contract, basically, the first of all, the address will change. Second of all, you will lose all the previous states. So, for example, let's say I deploy a contract ABC, and you, Prateek, you come and you deposit 100 tokens in that contract. But then I find, okay, this contract has a bug, and I decide to change the contract completely. I develop a new contract altogether, and basically, then two things happen. First of all, I change the address of the contract, so the identifier of my contract changes now. The community might know that my address was 0xabc, but now it's 0xbcd. Second thing is it lost all the states. So if you had staked 100 tokens, now it's all gone. It's into the new contract. Upgradable contracts, in a way, provide us a way to have two different things. So it gives us one contract, which is called the proxy, that stores the state of the contract, right? And the second contract is the implementation contract, which allows us to have the implementation logic. So implementation logic basically means that let's say we are defining a function ABC and it has three lines, right? And the third line is the bug, right? So if we ever want to remove that third line, we can basically upgrade or change the implementation contract, right? And basically remove that particular line. And the implementation contract address changes, but the proxy contract that has the state of the entire contract, that has the funds and the specific address, that doesn't change. So the way upgradable contract works is basically it has a proxy contract which has all the state of the contract. It is we don't touch it, right? But the proxy contract is pointing towards the implementation contract, right? And it's saying that the logic for execution should be taken from this contract, which is the implementation contract, right? Now if someday you find that okay, the implementation contract is wrong, you can basically just change the contract, implementation contract, deploy a new one, and make the proxy contract point to that new address. So now you have achieved two things. First of all, your smart contract address will always remain same because the proxy address is the one that you are giving to the community members. Second, you don't lose your state because you are upgrading and changing the implementation contract, but the proxy contract remains the same. It is not touched. So yeah, this is how in general how smart contracts work. I have an article actually as well that explains how it works. So maybe I can share that as well. Yeah.
Okay, great. So smart contracts, are they inherently designed with this two-tier kind of a system, a state contract and an implementation contract?
Oh no, no, no.
No.
Inherently, they
Okay.
are not defined like that. This is basically, what we call as the fixes that we're trying to come up with. Maybe in future we will have with more effective fixes. But this is, I mean, the community was really bothered about, that you can't fix your codes, and which is why the great minds they all put in their effort, and it has seen a long history. So initially we had a different mechanism. Now, which is very famous, we have a proxy-based upgradable system. These are not inherently designed in smart contracts. In smart contracts, by default, are immutable. You can't change them. This is just the fixes and the methods we are trying to implement. This entire proxy and implementation thing, this is not inherently in smart contracts. We are just trying to build things that helps us upgrade the contract. Yeah.
So this is like a workaround, and
Yes, exactly, a
okay.
workaround. Which is why maybe sometimes, I mean, recently there was a wormhole attack, and the reason behind that attack was upgradable contracts. So still, you can't really trust it completely, which is why security becomes a real priority. But yeah, this is something that we are using, and it has been proven to be effective enough.
Okay, great. So also you mentioned like the very famous DAO attack where Ethereum was stolen.
Yeah,
So
yeah.
there's been this debate. So is that a hack or is that not a hack? Because now that person is not actually hacking the code. Is only it's they are essentially agreeing to the terms of the contract, but they found a loophole on in the contract. So what are your views on that?
Yeah, that's a classic debate on if code is law or not. And I mean, this was the main discussion behind why Ethereum should be forked or not forked. My views is that that was an attack. I mean, see, if you are coming from the mentality that code is law and everything that the user is doing, even a malicious actor is doing, is basically agreeing to the contract, and which is very fine, which is really true. But when you are trying to wipe out all the Ethereum with a bad intention of not returning those Ethereum ever again, that comes under the attack category. And maybe I'm speaking this because I'm from the development security background, and maybe people who are from more of the code is law fundamentals, they might differ from it. But I believe it was an attack because they found a loophole. They could have informed us, informed the community that this could be fixed. But instead, they did a reintendency attack, or came to the contract again and again, wiped out all the Ethereum that was there. And yeah, it led to disastrous results. So for me, it was an attack, and it is still an attack if someone does that.
Right. So, you also mentioned there have been several kinds of these attacks. So, are the
Yeah.
attacks always exploiting the conditions, or have the actual code been hacked in any case?
Got it. Not always the conditions. I mean, most of the time it's logic errors. I agree with that. I mean, maybe sometimes you wrote a bad access control, which allows a malicious actor to be the owner of the contract. That's definitely a bad development practice, and you did something wrong while you're developing the code. Sometimes it's not even the fault of the developers. For example, attacks like price or like a manipulation, or like dumping the price of at 1 a.m. and trying to do an arbitrage trade, which basically wipes out all the token from the contract. These are more financial sort of hacks, and it requires a lot of financial knowledge as well. So yeah, I mean, not all attacks in Ethereum space is conditional. Some of them are financial as well, and maybe which is why I force, and even I try to learn a lot about finance and how it works, how arbitrage trading works, and AMMs work. Because only after you understand these things, chances are you will develop a contract that is much more secure than it could have been if you don't know anything about financial things. So yeah, not all attacks are conditional. Yeah.
Okay, sure. Understood. So, also, now coming to the concept of code is law, right? So,
Right.
that essentially means that we can
You love
completely
coming here.
objective.
That's a very interesting topic.
Yeah, indeed. So, that
Yeah.
implies that law can be completely objectified, right?
Mm.
That you can, but in essence, so how the current system works, right? So there is an objective law, but the court essentially has the power to interpret the law. So they have a subjective authority over what is written, right? So it's
Mm.
not completely the written meaning, rather a human subjectivity is allowed, which is
Mm. Mm.
perhaps needed. So what are your views on that? Can code be law, or will it always require human subjectivity and judgment?
Got it. I personally believe, considering the stage that we are in, code cannot be law. This is again a very controversial statement, but I think code cannot be law, at least in the state that we are in right now. And what you mentioned makes complete sense. Uh, Although the overall vision of Web3, like I mentioned, is to have an executable Magna Carta, which means code should have been law. But right now, with all the nascent stages thing that I just discussed, all the issues that we're constantly finding in the Solidity language itself, uh, code is not yet in that level that it could be termed as law. And I mean, although I like to have upgradable contracts, and maybe from a development perspective, I firmly believe that if a contract can be upgraded, it sort of distorts the vision of Web3 in general, which is, code should not have been changed. Once a code that is deployed on the blockchain, it should have been like that. But now with all these workarounds around upgradable contracts, I personally see it's a very tricky question, because I think upgradable contracts are important because it allows to fix bugs from a development perspective. But I also think they are sort of defeating the purpose of F3, or defeating the purpose that smart contracts should have been immutable. And how can you trust a law if it can be changed at any moment, right? That's a very tricky question. But maybe right now the justification that I can give you from the development side is, we are changing the code so that it could be better, or it could be more secure. But I mean, overall, I don't believe code can be law if it can be changed every now and then. So yeah, maybe that could be the answer for this. But I would love to discuss with you on this, Prateek. I mean, you do have very interesting insights on this. Yeah, I mean, I like to engage in such conversations because I mean, this is how you will probably end up solving this issue in Web3 that we have now. But right now, at least, I don't think code is up to the level to be called a law. Yeah.
Right, indeed. So, if I give you my understanding of
Yeah. Yeah.
of
Please.
this subject, so I believe we need something like a parliamentary system that we have today in Web3.
Hmm.
It is essentially a democracy that we will live. People can vote, people can choose. So you
Right.
need a law, which is code. You need you need something like a court who can then actually interpret that, who can probably give a judgment over that, and that can also that
Hmm.
everything, all of this can be facilitated in a Web3 economy through smart contracts. And
Right. Right.
so with the structure that we need is more like a parliamentary democracy. I believe that is the structure that we
Mm.
need, and that is the structure that we need to enable with smart contracts and this Web3 economy. And that possibly would work best.
Well, that's definitely a good idea. I mean, so are you sort of I mean, sorry, I have a red line again, but I would like to ask this. So
Uh, I'm sorry, Zarif, you're breaking.
can you hear me, Pratik?
Yes, yes, better.
Yeah, okay, sorry. Maybe my net is slow. Yeah, I was saying, although I have a hard stop at 8:10 p.m., but I would like to ask a question. I mean, it's very interesting that you have mentioned this. So are you thinking sort of a DAO that, through on-chain governance has this parliamentary like body, or is that a different idea? Because it's really interesting to hear the idea.
Yes, indeed. So a DAO, so a democracy, basically in the form of a DAO,
Hmm.
and we need all these bodies. We need a Supreme Court, we need a parliament, we need an executionary body, like we have today. So we have to mimic. See, I believe the constitution that has developed, our social system, our political
Hmm.
system, this has been developed through a lot of turmoil, through a lot of it is time tested. I would say the parliamentary democracy that is working today. So I think we have to mimic
Right.
that system through code because we already have a system that is working. We don't have to reinvent the wheel.
Right, right, right. I mean, the time tested part is really interesting to me because we don't have anything time tested yet in Web3. We are just experimenting with different things, and if we have something, which we know has worked well over time, maybe yeah, that could be a great idea to have. Let's have more conversation on this one. Maybe we could find a solution around this.
Yeah, indeed, indeed. So, Zaryab, keeping in mind the time limitations that we have, it was great to have you, and I feel you have
Sorry
a
about
lot of
that, man. Yeah, I just have a hard stop.
yeah, no problem. I feel you have a lot of passion towards this Web3 and blockchain, and it was great to meet someone like you.
Definitely, man. Definitely. And keep up all the good work that you're doing right now, spreading this Web3 economy and the education part of it, actually. So, yeah, really great. Thanks for having me. Hope to be here
So,
again with the code is law discussion.
sure, indeed, another time.
Sure, man. So, yeah, that's me signing off. Thanks a lot, Prateek. Thanks a lot, IDS. Thanks for having me.